Have you ever pondered about the cosmic clouds that give birth to stars, planets, and perhaps other forms of life? Welcome to our journey through the cosmos, where we are going to explore the mysterious and awe-inspiring nebulae. Picture this. A nebula, in its most basic sense, is an enormous cloud of dust and gas that hangs in the infinity of space. It's like a vast cosmic fog, swirling with particles and elements, stretching across light years of space. Now, what makes these nebulae so special? Well, when we gaze out into the night sky, each star we see is a testament to the life-giving properties of these nebulae. Yes, that's right. These seemingly tranquil clouds are the birthplaces of stars and planets. They are the cosmic cradles where matter comes together, driven by the forces of gravity, to form new stars and planetary systems. Imagine a nebula as a colossal maternity ward in space. Tiny particles within the nebula start to clump together under the influence of gravity, growing larger and larger over millions of years. As these clumps gather more matter, their gravity increases, pulling in even more particles from the surrounding nebula. Eventually, these growing spheres reach a critical mass, triggering nuclear fusion and igniting the birth of a new star. But it's not just stars that are born from nebulae. Planets, too, are formed from the leftover dust and gas that swirls around these newborn stars. This cosmic dust and gas coalesce into a spinning disk around the star, gradually forming planets, asteroids, and comets. So the next time you look up at the night sky, remember that each twinkling star, each planet you can see, has its origin in these vast, beautiful cosmic clouds. Nebulae are not just distant, abstract concepts in the realm of astronomy. They are active, dynamic regions of space, where the raw materials of the universe come together to create the celestial bodies we see in our night sky. So, nebulae are essentially stellar nurseries, where the life cycle of stars begins. Join us as we delve deeper into the colors, sizes, and life cycles of these fascinating cosmic phenomena in our next scenes. Ever wondered why nebulae are so colorful and vibrant? This kaleidoscope of colors that fills up our night sky is not just a random act of cosmic aesthetics, it's a product of the types of gases present in these nebulae and how they interact with light. Let's start with the basics. Nebulae are essentially vast clouds of dust and gas in space. These cosmic clouds are made up of different types of gases, each contributing to the color spectrum we see. The primary gases found in nebulae are hydrogen, helium, oxygen, nitrogen, sulfur, and a smattering of other elements. Hydrogen, the most abundant element in the universe, gives nebulae a characteristic red color. This is because hydrogen atoms emit light in the red part of the spectrum when they are excited. So, when you gaze up at a nebula and see shades of red, it's the hydrogen you're seeing. Next up is oxygen. Oxygen in nebulae often gives off a green-blue hue. This is because excited oxygen atoms emit light in the green part of the spectrum. So, when you see green-blue shades in a nebula, you're essentially seeing the oxygen at work. Then we have sulfur. Sulfur in its ionized state also gives off a red light, similar to hydrogen. This makes the red hues in nebulae even more intense and vibrant. Now you might be wondering, if hydrogen and sulfur both emit red light, how can we tell them apart? The answer lies in the specific wavelengths of light they emit. While both are red, they are subtly different shades of red that can be distinguished using spectroscopy. These gases, when combined with dust particles and the energy from nearby stars, create the breathtaking, vibrant scenes we see when we look at images of nebulae. Each nebula is a unique blend of these elements, resulting in a wide spectrum of colors and shapes. So, the next time you look up at the night sky and marvel at the colors of the cosmos, remember that these cosmic clouds are not only star factories, but also nature's own cosmic art gallery. Can you fathom the sheer size and distance of these galactic entities? Nebulae, the celestial nurseries of stars, hold an almost incomprehensible vastness. Their size may seem unfathomable, but let's embark on a journey to grasp their magnitude. Imagine this. Some nebulae span hundreds of light years across. Yes, you heard right, hundreds of light years. A light year, for those who might need a refresher, is the distance light travels in a year, roughly 6 trillion miles. So when we say a nebula is hundreds of light years across, we're talking about an expanse so immense that it could take light itself centuries to cross from one side to the other. But the size is just one part of the story. The distances to these nebulae from our home planet Earth are equally mind-boggling. Take, for instance, the famous Orion Nebula, one of the closest nebulae to us. It's located in the Milky Way, about 1,300 light-years away. That means the light we see from the Orion Nebula today actually left it around the time that the Magna Carta was being signed back in the 13th century. Or consider the Carina Nebula, another one of our galactic neighbors. It's a staggering 7,500 light-years away. The light that we're currently seeing from the Carina Nebula began its journey around the time when humans were first learning to farm and build settlements. It's a humbling thought, isn't it? We're not just looking into space when we gaze at these nebulae. We're looking back in time. And while these distances are enormous, they're just a tiny fraction of the scale of the universe. Even though they seem close in the night sky, nebulae are incredibly far away, reminding us of the immense scale of the universe. So next time you look up at the stars, remember, the universe is not just vast, it's filled with wonders that are both beautiful and incomprehensibly large. Do you know where stars come to life and eventually die? The answer lies in the boundless, vibrant expanses of nebulae, the cosmic nurseries of the universe. The life cycle of stars within nebulae is a fascinating tale of creation and decay, a celestial ballet choreographed by the laws of physics. In the beginning, there's a nebula, a vast cloud of gas and dust particles. Within these nebulae, there are denser regions. Under the influence of gravity, these denser regions collapse inwards, triggering the birth of a star. It's like a cosmic seed sprouting into a stellar sapling. During this collapse, the core of the region heats up, forming what we call a protostar. As the gravitational collapse continues, the temperature and pressure in the core rise until they reach a critical point where nuclear fusion begins. This is the moment a true star is born, radiating light and heat into the cosmos. A star, once born, spends the majority of its life in a phase called the main sequence, where it steadily burns hydrogen in its core. This stage can last for billions of years, depending on the star's size. The larger the star, the shorter its lifespan. Eventually, the star exhausts its nuclear fuel. What happens next depends on the star's mass. A star like our own sun will swell into a red giant, shed its outer layers, and finally shrink down to a white dwarf, a dense stellar remnant. Larger stars, however, meet a more dramatic end. They explode in a supernova, outshining entire galaxies for a brief moment before collapsing into a neutron star or a black hole. But the story doesn't end here. The material shed by dying stars returns to the nebula, enriching it with heavier elements. These elements will eventually form part of new stars, planets, and possibly life. This cyclic process of birth, death, and rebirth is the lifeblood of our universe. Stars, much like us, have a life cycle, and it all takes place within these vast cosmic nurseries. Why should we care about these distant, colorful clouds, you might ask? Well, nebulae are more than just eye candy for astronomers and space enthusiasts. They offer us a window into the very heart of the cosmos, and their study holds the key to unlocking many of the universe's greatest mysteries. First and foremost, nebulae serve as stellar nurseries. The gas and dust within these cosmic clouds collapse under their own gravity to form new stars. Studying this process gives us insight into the birth, life, and death of stars. It helps us understand how stars like our sun came to be and how they will eventually meet their end. Moreover, the elements found within nebulae are the building blocks of the universe. They contain hydrogen, helium, and traces of heavier elements. Nebulae are basically cosmic laboratories where these elements combine and recombine in endless permutations, and observing these processes helps us understand the composition of the universe itself. But perhaps the most exciting aspect of studying nebulae is their potential to shed light on the origins of life. Some nebulae contain complex organic molecules, the precursors to life as we know it. These molecules could have been delivered to the early Earth by comets or meteorites, sparking the process that led to the emergence of life. In other words, when we study nebulae, we're not just looking at distant, colorful clouds. We're peering into the cradle of stars, contemplating the raw materials of the universe, and possibly even gazing back at our own cosmic origins. So the next time you marvel at the images of these beautiful, distant clouds, remember, they're not just there to look pretty. They're working hard, birthing stars, brewing elements, and maybe, just maybe, holding the secrets to life itself. Nebulae, the cosmic clouds, are more than just beautiful to look at. They hold the secrets to our universe and perhaps even to our very existence.